Hi, my name is Liam Johns from the University of Auckland. I'll be presenting about auditing archaeological material for data integrity. Since 2012, the Ahuahu Great Mercury Island Archaeological Project has undertaken fieldwork approximately 3 times a year for several weeks. Over the course of this fieldwork, we have excavated and collected over 80,000 piece provenience artifacts. As we will discuss, this presents challenges relating to the management of the metadata associated with the objects, particularly in the context of an ongoing project. To this end, we implemented an audit process of the collected material. This process has increased the quality and integrity of the dataset, and I will go over some of the issues and findings that have arisen over the course of the auditing process. Just for context, Ahuahu is an island on the eastern Coromandel coast of New Zealand, occupied by Maori since the 14th century at the earliest phase of Aotearoa's history until the period just before European arrival. The island has been excavated since 2012 by the University of Auckland in partnership with the Auckland Museum. During excavation and survey of subsurface and surface deposits, we record the provenience of every artifact over 20 millimeters. This involves the spatial recording in situ with a total station, with the object labeled separately and placed inside a plastic bag. Information on the label includes the unique identifier assigned to the object and information relating to the deposit it is from, the trench area number, and the interpretation of what the object is. This is a broad assignment of a fire-cracked rock, bone, or stone artifact, for example. These objects are then transported back to a field lab, where every evening the information on the labels is recorded into tablets and preliminary checks are run. The most common of which is any cases of artifacts which are mistakenly identified as the wrong type of object, which are then corrected in the field. This is typically managed by one person across the season, with assistance typically derived from students on excavation. The registered data is then cross-referenced every night with the spatial data derived from GIS, which enables for any missing artifacts to be identified and unique identity numbers that may have been recorded incorrectly on the GIS to be corrected. The artifacts are then packaged back for transport back to the mainland. At the end of each fieldwork season, the data is compiled into the master database and the artifacts returned to the University of Auckland for further processing. Artifacts are cleaned and sorted into excavation units, material types, and placed in trays for further analysis. The assignment of the artifact in the field and any revisions during the evening registry are in some cases the final assignment of object type until further analysis is undertaken. Analysis is undertaken by staff and students alike, either on entire assemblages or samples. As a result, objects were moved to temporary storage areas before being returned to the main collection. This occasionally resulted in objects being placed back in the wrong place. Also, over the years of collection, some common errors began to emerge, mainly that objects were not necessarily correctly identified in the field. To rectify this, an audit was undertaken of the 80,000 objects to fully rectify the identified potential for some data quality issues, but primarily to effectively maintain the Great Mercury Island Archaeological Project's artifactual inventory as one that meets high standards of data integrity. To clarify, the term data integrity is used to refer to the completeness, consistency, accuracy, trustworthiness, and reliability of data, while data quality is referring to the match between data generation and the intended use of the data. In total, to audit the approximately 80,000 artifacts brought back from excavation, it took a total of 40 months, including the pilot stage of the process. In terms of process, we systematically examine the contents of each discrete storage unit, aiming to move through the assemblage without allowing audited material into the unaudited sections, and vice versa, requiring the use of a basic inventory control system, allowing us to precisely locate audited material in storage units within the lab. This took buy-in from the wider Great Mercury Island Archaeological Project team, and careful controls. In terms of the actual data, we recorded the full range of artifact provenience as recorded on the label. Secondly, artifact material and type was reassessed, focusing on artifact material composition rather than functional usage or attributes. Further recording was taken in terms of artifact conservation, and we were constantly checking and looking after the status of the object. This work was undertaken entirely by graduate students at the University of Auckland working part-time, ranging from between 2 to a maximum of 5. This number fluctuated as people were brought on and left. We used 2 principles of data management to inform on the process and its desired outcomes. The first being the FAIR principles of data management, an acronym for findable, accessible, interoperable, and reusable, which really stresses the need for consistency in data sets in addition to coherent metadata creation, both in terms of potentially opening up data for outside use, as well as improving the quality of research for in-house use and the ability to maintain the integrity of the dataset. The second data-related principles have been the CARE principles for indigenous data governance, this being an acronym for collective benefit, authority to control, responsibility, and ethics. It has been an important aspect of the audit and fieldwork to incorporate these principles in our relationship with the tangata whenua of Ahuahu, that being Ngāti Hei. In the university's role as temporary kaitiaki, or custodians, of the archaeological material, it's important that we maintain the highest standards of data integrity, not just to preserve relevance to science and archaeological research, but also as the role of data as living taonga to Māori. These broad principles have formed an especially useful and very relevant method of managing data within a Māori data context, and will very likely be of just as much relevance throughout the world. Whilst doing this audit of material was the primary goal of the project, a major step in the process was checking the integrity of the quality checking process. We achieved this by re-auditing 2 samples of the material, one to test the validity of the error checking done randomly across the assemblage, and the other to test the accuracy of our data in relation to storage units, to pick up what was missed or perhaps had been moved since. The first aim of this process was to establish error rates across the various fields in the data process. A sample of 5%, or just under 4,000 objects, was to provide a sample testing the quality of the data cleaning of the entire assemblage. This provided a data set that would represent the quality of the audit throughout the 14th month-long process. We took an additional random sample of 2.5% of the storage units and recorded the contents of these to check the integrity of the inventory controls implemented as part of the re-audit. There was overlap between these 2 groups, but only in 71 cases. As a result of this inventory check, only 25 objects, or 1.74% of those examined, were identified as being stored in an incorrect place. In the primary data quality checking process, a disagreement percentage between the audit and the re-audit of 1.57% was found. While some of this error persisted in the form of random errors, such as mistyping, the issue of human and systematic error presented a much more significant source. These random errors were highlighted in some specific categories, particularly in longer strings of numbers that were noted to be a relatively minor source of error. Human error, being that which results from misidentification, due to the relative ease of identification in these categories, is likely to be a relatively minor component of the observed total error, except in niche edge cases. Notably, a key source of error that was recognized in this process was the systematic error in interpretations amongst the auditing workers regarding specific aspects of the protocols. For example, designating the type of shell as unidentified rather than not applicable, for a minor example. Another example is a difference in understanding of the role in which outside registry data could be used to fill in missing parts of the labels, which resulted in the same artifacts receiving a date, whereas in the re-audit it wouldn't, for example. Problems and errors like this are difficult to mitigate completely, but in our case sought to drive home the importance of clear and extensive documentation of protocols to avoid small errors such as these from accumulating during a checking procedure. Potentially, errors like these could be solved at the data entry phase by cleaning inputs through data entry programs and taking away potential for individual interpretation of schema protocols. The increase in workforce about 6 months into the project from 2 to 5 students is correlated with an increase in percentage error. However, this occurred at a simultaneous switch away from simpler parts of the assemblage, that being obsidian, which is generally quite easy to identify, to more diverse assemblages, such as lithics and bone, which present more potential error in interpretation, particularly in interpretation of edge cases. Initially, we underestimated time, resulting in the increase of personnel from 2 to 5. Bringing on more people did increase efficiency, provided they were trained to the same level. These examples of issues that only really came up in re-auditing demonstrate the need for critical and reflexive examination of the checking process. By re-auditing the audit, we're able to quantify the integrity of the dataset. Without this re-audit, it would have been simply generated another set of data that, whilst more consistent, would lack integrity due to its lack of transparency and qualifying of the actual error rate of the check. The reflexive examination of procedures was key in allowing the further development and refinement of methods, allowing us to understand how practical matters like the implementation of protocols can affect the quality of data checking, in addition to the more qualitative aspects of identification of where protocols have failed. One of the first things learned from the process is that data derived from in-field registry is often error-prone due to a variety of factors, often involving unavoidable practicalities in the field, as well as the impact of changing methodologies. As a flow-on from excavation, inventory must be maintained and checked, with problems such as students and staff placing artifacts back in incorrect places after analysis being a problem that at the time of the audit, 7 years, these errors can accumulate. Perhaps one of the key realizations is that ensuring data integrity is kept to its highest is that it is not a static process, and nor is it necessarily an inexpensive or straightforward process. While the Ahuahu collection represents 80,000 artifacts under the same continuous project, still a significant amount of effort was needed to create protocols for dealing with a broad collection of material in varying states of inventory quality, as well as dealing with subtle shifts in recording methods. Additionally, further use of technology, including collections management systems and improved data entry procedures, will likely provide much benefit. However, with this expenditure of time, effort, and money, this has resulted in a data set with a measurable level of integrity, which allows us to be confident in using a coherent, quality data set for research, as well as responsibly creating and storing metadata. Furthermore, this initial audit has been an especially useful learning experience for developing methods and protocols for both the Great Mercury Island Archaeological Project and for any future projects. Increasingly in archaeology, there is a pressure for data access from both the perspective of open data, but also the perspective of indigenous data governance, the FAIR and CARE principles respectively. Both of these principles innately require that data integrity and quality be maintained and considered constantly. Assessments such as the one undertaken by the audit of Ahuahu's artifactual collection can form a key part in asserting the integrity and quality of data, enabling the project to fulfill obligations under both principles, opening the way for the potential for datasets to be widely disseminated, providing benefit to both the archaeological community and indigenous groups. Thank you.